Okay, so thanks everybody to be here for this talk. So I'm actually learning a bit of Turkish, and I wanted to welcome you by saying Merhaba kediciklerim. So I hope it's okay. I asked Nursel if it was okay. She told me peki, so I hope it's fine. Well, it's just the beginning of my learning. I guess I cannot have a normal conversation. I am Nicolas Frankel. I've been a developer. Well, I've been working in technical roles for like 18 years. And since 2 years, I'm a developer advocate. I'm used to like work in enterprise techs. So formerly it was Java E. Now, at the end, it was more Spring Boot. I love Spring Boot. And I work currently for a company called Hazelcast. Hazelcast has 2 products. The first product is called an IMDG, in-memory DataGrid. And since I will be highlighting some of its features throughout the talk, I won't talk about it further. The second one is called JET, and basically it leverages the in-memory features of Hazelcast IMDG to build an in-memory streaming pipeline. So it's very good when you need to process your data very, very fast, because everything stays in memory. You don't need to persist it to disk and to read it again. This talk is about how you can, let's say, improve your microservice architecture. So first, before diving right into the subject, it needs some context. What are microservices? And I won't read the slide because you can read it by yourself. But this, you can find it on Martin Fowler's blog. I think it's pretty comprehensive definition. And the important bit of that is that at the beginning, there are a lot of technical features of microservices. To do microservices, you componentize your code base through services and so on and so forth. And one of the issues I see very often is that basically technical people are using those definitions, so they only check the technical requirements. And they don't care about the rest because it's out of their scope. So for example, if you go down to the last point, products, not project, this is outside of our reach. We don't organize the company. We basically architect the products or the software, but we have no saying in general, at least, in how we manage the budget. And that's one of the main issue when people say, hey, we are doing microservices, is basically they are not doing microservices because of this last point, because most of the thing I see around are actually projects. And the difference between a project and the product is a project has an end date. So you have a budget, it starts on date X, it ends on date Y. And on date Y, you need to deliver all the scope. And you cannot have a microservice architecture if you work like that. So if you are not doing microservices according to that definition, that's fine. You don't need to have microservice architecture on your CV, believe me. Actually, if you read further on Martin's Fowler blog, and I will touch some points of it, you will actually find that it requires a lot of maturity to do this kind of architecture. So don't worry, it's fine. What you can do, however, is web services, and of course, it's a good idea in most cases. If you have microservices, that's a benefit. One benefit is scalability. And you need to understand something. Like I usually have this example of this e-commerce architecture. So basically, I have an e-commerce architecture based upon microservices. So I have wrapped around each feature around a microservice. So basically, there is a microservice that displays the catalog. I have a microservice that handles the cart management. I have a microservice that does the checkout. I have a microservice that does the payments, and so on and so forth. And as you know, if you are doing e-commerce, there is a funnel. So basically, you have a lot of people browsing the catalog, then you have less people putting stuff in the cart, and then you have less people doing the checkout, and you have even less people doing the payment. And now imagine we need to scale horizontally. We need to add more machines because we have a lot of more users, more customers. And if you have monolith, basically since every one of those features is in the same component, is in the same deliverable, then you will deploy nodes that handle that. But in the end, you will deploy according to the feature that is the most used, which is the catalog browsing port. And so you will still deploy the payment feature anyway, but it won't be used at all. And by doing microservices, you can scale those features independently. So you can scale a lot more catalog browsing microservices than payments microservices. So that's one benefit. It's about scalable deployment. And now, since we are talking about scalability, you are not there. We are not in the same room, so I cannot see your face right now. But that's supposed to be a joke, of course. So here on the left, you have a diagram, a UML diagram, and on the right, you have another UML diagram. And I would like you to take like 5 seconds to answer by yourself if you can spot the difference between those two diagrams. So, and the answer is, of course, there is no difference between the two diagrams. And that's an issue because if you are an architect, those two diagrams are the same, but they can be used to describe two different realities. So, for example, on the left, you would say, this is a call inside the JVM. So this is an API call inside the JVM. And on the right, this is a microservice call. This is an HTTP call, and it goes through the network. And it would be designed the same way through UML. And as an architect, I've been an architect, so I can say bad stuff about them because I believe I'm an architect myself. So I'm part of this. I can say, oh, and well, we have this stuff, and it's an implementation detail that it goes through the network, and then the developers needs to figure out all the bad stuff about the HTTP call. Because when you start doing HTTP calls, when you go out of your JVM, then you are basically doing distributed systems. And distributed systems, of course, they are hard, but the first thing is when you start doing HTTP call, you are actually slowing down your software. So the fun part is if you are having performance issues and you say, oh, I will scale my software. And in order to scale, I will implement a microservice architecture. And so you are adding this network latency between the calls, and you are actually slowing down your software. So if you have performance issue, in microservices architecture won't help you at all. And also you have this fun part of distributed computing. And I encourage you to look upon it on Wikipedia. It's very funny. Just print it out, put it in your office. Every time you do a distributed call, a HTTP call or anything, then you need to think about that. When you are inside your JVM, what happens is basically you are making the call, and it can succeed, or you can have an exception. But if you have an exception, basically you have a response. What can happen with a network call is you make a request and you never get the answer. You never get the response. So you need to handle the timeout. And worse, you don't know whether the server got the request and you didn't get the response, or that the server never got the request. And yeah, latency is not zero, blah, blah, blah. You've got everything. So there's actually this little diagram that I showed is actually, if you want to represent it, is much harder. Huh? It looks much more like that because you have a lot of layers, and they can be software layers, but they can also be network layers. They can be like the ISO layers. And if you think that afterwards you need the response, then it looks more like that. Now you understand that why it's super slow, because you need to go through all those layers. notwithstanding the fact that you will never happen to be sure to get the response anyway. So if I tell you something is slow, in general, what engineers think, hey, let's set up some cache. And that's a very, very reasonable thing to do. You just need to understand, just like everything in software, it's a trade-off. So basically, when you are setting up a cache in front of some resource, you are improving your performance, but you are actually paying the cost that the data you will read won't be up to date, or at least let's say that you are not sure it will be up to date. So there is no magical answer to everything. Caching is good, but then you won't be able to guarantee you will have the latest data. Once that is said, of course, you might know these fun parts about caching. There are two hard things in computer science: cache invalidation, naming things, and off-by-one errors. So the first thing when you want to set up caching is generally, I will use a hash map. It can be a Python dictionary, a Java hash map, or whatever. I mean, I've been guilty of that. I wanted to improve my performance. It was not an issue that the fact it was not up to date because it would not be written afterwards. I just wanted to keep the data close to me, and then I used a hash map. But if you start using a hash map for caching, you will run into some issues. The first is a hash map has no size limit. It will grow without any bounds. And so the more you put stuff, the more it will take place in memory. And at some point, you might explode into an out-of-memory error just because of that. So now you say, okay, I will limit the size. But then what happens when you put an additional data item that goes over the size? Then you need to implement some eviction strategy. Like it can be list frequently used, list recently used, this kind of thing. And I told you about cache invalidation. So when is the cache no longer valid? So you need to implement another feature, which is called time to live. So when you put an item into the cache, you need to set up how long it will live inside the cache until it goes away and you need to go to the data source again. And all those features, they are hard to implement. You can do a lot of wrong code. So if you need a cache, please use a real cache solution. It can be Hazelcast, it can be another one, but please don't implement a cache by yourself. So Hazelcast, as I mentioned, is this in-memory data grid, and you can think about an in-memory data grid as a distributed data structure. So I've talked about the hash map, and imagine you have a hash map in memory, and then because, let's say, it's a huge hash map and it takes a lot of place, you want to say, oh, but I just want to keep half of it in this node, and I want to keep the other half in the other nodes. Then this is called sharding. And of course, the more nodes you have, the more shards you have, and the smaller each map is. But of course, that means that if you are running code on one node and it doesn't have the data, it needs to ask for another node for the data. And in that case, it's additional performance hiccup. So you can say, oh, but then I will have a bigger map. And the more data you put into one place, the more unique data. If the node goes down because it's in the memory, then you will lose data. So another thing that an in-memory grid does is basically it allows you to have some replicas. So for reasons that performance, you want to keep as many replicas as possible, and also the fact that you want to keep the data safe, even if one node goes down, you might want to replicate data around your nodes. But then you've got another, you will encounter other issue that if data on one node changes, you need to replicate the changes on other nodes. It's a real job. That again is the reason why you should always think about using a professional in-memory DataGrid. So now that it's said, here I will present you 3 different places where this caching stuff can help you, or I would say in-memory DataGrid can help you, because the last point is not about caching, it's about replicating session data. So the first is data access. The second is a call for a REST call, HTTP call, and the third is about session replication. I will use a Spring Boot application, so I hope that in a conference called Java Day, a lot of you people are using Java, and most of you are probably using Spring Boot, but you can do it in Tommy or Java E, like in the same way. If you are using Spring Boot and you have data access, there is something very nice that's called Spring Data GPA, and Spring Data GPA relies on a framework, on a specification called GPA, and GPA by default in Spring Boot uses an implementation called Hibernate. And I infer that most of you have heard, or if not used, Hibernate, and basically it's just an ORM framework. So you define your entities, they map to table, and you define the relationships between them, and of course they should map the relationship between the table. And Hibernate has actually already some cache by default. So when you get a handle on the session itself has a cache. So if you do with the same session, you do twice a load of the same entity, only the first one will go to the database, and the second one will directly read from the cache. So by default, you already have this cache. But as I mentioned, it's bound to the session objects. And if you are in a web scenario, which most people are, if you are in this web scenario, the session object is created at every HTTP call. So you have an HTTP request, you, through a filter or whatever, create the session through the session factory, you do your requests, you return the response, you serialize it in HTML again, and the next HTTP request, you have a new session object. So the cache is empty again. And if you want to improve upon that, what you can do is set up a level 2 cache. This one is optional, it's not enabled by default, and there are multiple integrations available. And of course, Hazelcast is one of them. And basically, you can do read-through, and read-through is basically you do the query with Hibernate. Hibernate will try to read the key from the cache. If the cache doesn't contain the key, it will load from the database and put it in the cache. And the next time you try to load again, then it will look in the cache, it will return the value because it has found the key. And every time you do a write, then basically you either create or update the cache value. So this is pretty simple. So I have a bit of a demo because I think that if I've just talked, it's super boring, both for you and for me. So I have this stuff and I need to change it here to this project. So here I have created, as I mentioned, a Spring Boot project. As you can see, it uses the latest Spring Boot. I don't want to have fancy Java stuff, so I'm using 1.8. I'm using the starter of GPA, the starter of web, because then everything is set up for me. I just need to override to the latest, versions of this Hazelcast Hibernate integration, and also bring in the latest Hazelcast version. And the rest is pretty standard stuff. Of course, I don't want to set up a real database. I'm using H2. So H2 is an in-memory database. So having an in-memory cache in front of an in-memory database is not very relevant. It's not a great idea. But for the purpose of this demo, it will be more than enough. I have a person controller, And basically, this person controllers has two endpoints, one that returns all entities, one that returns a single entity, or if it doesn't find it, then nothing. And it relies on the person repository. As I mentioned, I'm using Spring Data GPA, so I'm just extending an interface, and at runtime, Spring Boot will create all the necessary classes, and it will give me an implementation of this find all and find by ID. That's what I love Spring Boot's Spring Data GPA. And as for the data, I have this data.sql. So when I start the application, my database will be populated with that. So let's start this application. And in order to show you that actually I have caching enabled, what I did is I enabled the statistic of Hibernate. So every time I will do a query, I will have this log that will tell me what happens. And you can see, you have this, level to cache hits, misses, and puts. So let's do some curl http localhost 8080/d/1. So I've got this return. And now I can see that since I've just started, my cache has been empty. So I have 0 cache hits, and I've got 1 miss. And then because it was a miss, what it did is it went to the database, and afterwards it did 1 put. Now, if I do the same request again, we can see on the second time that there is no JDBC request. So we never went to the database. We directly got a hit, and we returned the entity from the cache. And how do you do that? Well, you need a couple of stuff, but it's very simple. Actually, you need to say that this entity, this GPA entity, then you need to set up the cache region, and how you will actually get the cache. If you want to have, like, if many different services can update the cache or not, because then you won't take the same code path to ensure that you have the right entity in the cache. And then from a configuration point of view, you configure Hazelcast in that case. So the good thing about Hazelcast in that case is Spring Boot will detect there is a hazelcast.xml, and it will create an Hazelcast instance as soon as it detects this at startup time. And finally, the configuration itself is those 5 lines on configuration. And here I'm saying I will use a second level cache. Here I'm using also a query cache. So basically, when I create a select joker from a table, so I select multiple entities, find all, for example, I will show it just afterwards. It returns me everything, and then it puts this query into the cache as a key, and the value, it will be the IDs that were returned. So if I do this query again, if I do a load from one of the single key again, then it will be in the cache. I can show it to you. Now I will return everything. So I have those, I can do JQ. I will do JQ so it's easier for you to read here. So I have got my all 3 entities, and now I have all of them in the cache. So if I query for the third one, and the third one was not queried before individually, we can see that actually here I have a hit. So now all the 3 entities are in the cache. So pretty simple to set up. One additional dependency, couple of configuration lines, and you are set up. Pretty cool, if you ask me. Now, next one. Oh, I showed you how you could handle that with Hibernate, but actually every time you manage through Hibernate, you still sometimes need to do database access. So if you want really fast performance, but there is a trade-off, of course, there is no warranty. What you can do is, or you can only interact with hazard costs, both on reads and on writes. And then you have a listener that when you do a change, so when you do a write, when you do an update, then it will synchronize with the database in an asynchronous way. But since it's asynchronous, there will be no guarantee in the end. So you might not be sure about the consistency of the cache, but it will be very fast. So again, it's a trade-off. Now about the second use case, which will be a HTTP call. You could implement that manually, of course, but if you look in the Java specification, you will notice there is a Java API for caching, and it's called JCache, and it's a specification, and there are multiple implementations. And one of the implementation is Hazelcast, of course, and JCache can be integrated with Spring. And now let's go back to my e-commerce architecture. I have the checkout service, and this checkout service will need to ask about the prices. So when the person wants to do the checkout, you want to check the prices one last time. There might have been changes, you don't know. And the problem is what happens if the pricing service is down? What happens if it's too slow? What happens, etc., etc. You don't want to leave the person hanging. You don't want to tell the person, hey, come back later, we cannot access the prices right now. What you want to have is you want to have a fallback. And what better fallback than the prices that you loaded previously? So this is a very good use case for cache. So let's do some more demo. I hope that you can see my screen, because when I look upon it, I cannot see everything, and I'm a bit surprised. Yeah, yes, so it's not only for me, I have no clue. The last time I used this software, I had the same issue, so I hope that it will be fixed, but it's not great, because here, perhaps if I resize the window, so I'm really sorry, dear attendees. I will try to be, I will try to put the codes on the far left. So the second step is actually to do some HTTP calls. So for that, I prepared the code, and here I will directly go through Spring Cache, because I could use Spring Cache, Spring, JCache, and then Hazelcast. But then it would be like two abstraction layers that are not great. So I will directly use Spring Cache, and Hazelcast is also a Spring Cache implementation. So here I added another controller, and this controller basically uses the caching service to get to the database, and the caching service, the only thing that I need to do is this. So I add this annotation, cacheable, and every time this method would be called, basically it will do a put here on the long. Well, the first time it will do a put, so here this will be the key, and this will be the value. And the second time it will check that in the service map there is already an ID of type long, and if yes, then it will directly return the person. And it's up to the cache implementation to handle the time to live or whatever. So let's run that code. And let's do a curl. And now I have another, it's OR, so I will do curl, and I will do a curl of L1. And here, how can I persuade you that it is the correct data? If I do a second time, how can I be sure that it actually was in the cache? It was returned in the cache. There is no statistics on this caching service. So here, what I need to do is I need to start something that we call the management center, and that so far all that I've showed you is open source, is free. Management center, unfortunately, right now is not. It's part of the enterprise offering, but for us, it will do right now. I can show it to you anyway. And you can implement it by yourself if you have a lot of developer time, or you can, of course, as I mentioned, acquire it. And here, if I go on localhost 8081, and here I need to remember the password every time. And we can see there are different maps here, and one of them is called service. And here you can see that there is 1 entry. We did 2 gets, the first one, and we had 0 hits. And so the second one got 1 hit. And you can see there is 1 entry. So if I do it again one more time in my IntelliJ, then I will have an additional get at some point and an additional hit. And now I can be sure that I'm really using the cache. The last point is about session replication. So to tell you a bit about the context, it's very rare when you deploy your application that you run on single nodes. What you probably have is you have multiple nodes, because if you have a single node, there is a non-null chance that that node will crash at some point. And you don't want that. You don't want your node to crash and your customer or your user to say, oh, I cannot access the service. So what you do is you have those multiple Tomcats or whatever. And then when you do a request, there is something in front called a load balancer. Here it's an Apache server, but you can have Nginx or whatever you prefer. And this load balancer directs you to one node. Everything is fine. So at one point, it will direct you to node 1. At another point, it might direct you to node X. The issue that comes with that is, in general, you have states. Like, imagine again, you are in this e-commerce scenario, and you want to keep the cart. So one way to keep the cart would be to use a dedicated database. But it can be a real problem, a real performance bottleneck, because if every time you need to display the cart, you need to go to the database, that's an additional trip to the database and getting back again. In general, cards, for example, you want to keep them in memory. But it will be in the memory of one dedicated node. And what happens if you go to another node? Well, your cart will be empty. And that's not something you want. So in order to cope with that, you might have heard about session IDs. So session IDs are kept by the load balancer here. And once you have been directed to one node and it returns a session ID, the load balancer will keep a map of all session ID and all nodes where the next request should be redirected again to. So you will always be directed to the same node again and again, and you will keep your cards. And you might have heard that this is called sticky sessions. And everything is good, everybody is happy. But now let's go back to square one. What if this node fails? Well, if this node fails, we are back to square one, because the next request will go through the load balancer. The load balancer knows this node can no longer accept request. It will direct you to the other node, which basically has no session data, cart empty again. So Again, we can store in the database, not a good idea. What we want to do in that case, we can do session replication. So we can keep this little blue stuff here in sync with another one here. Is there any standards to do that? Unfortunately, there is none. There is no standard. However, Hazelcast can help you there. We have several integration points at different levels. So if you are running in the one, you can use a filter-based integration. If you are using already Spring Session, Hazelcast is a Spring Session implementation, or you can directly integrate so that your application is completely oblivious to that, and you handle everything in Tomcat. So you can configure Tomcat, and your application is completely session replication concern free. And of course, it also goes through Jetty. And if you want, you can, if we are using, since we are using Spring Boot embedded so far, we can also do that with Spring Boot embedded. And that's what I will show you right now. So I will just advance at the end. And don't worry if you are interested about the codes, because yeah, it's cut, I can see that. Then I have a link at the end where everything is in a GitHub repo, and I will share that link. So what I have here is something I have session data. And this session data is just a data structure with a string, which basically I will fill with the session ID and with a counter. And I have a session data controller. And when I receive something, I will use something called a session data handler that I injected, that you will read the session data and increment the counter. So if I have no session replication, what will happen is I will go to one node. So imagine we have two nodes. I will go to one node. I will ask, hey, give me the counter. It will return 1. And if I have this load balancer with basically a round robin, on the next request, it will direct me to the other node, and I will ask it, hey, give me the counter. There is no session replication, so session is empty. It will return me 1 again. And on the third, it will get back to node 1, and it will return me 2, and then 2, and then 3, and then 3. And that's not what I want. What I want is I will go to the first request with no session, return 1, and then I'm completely unaware what happens. I'm just like asking the load balancer. On the second request, it directs me to the other node, and it returns me 2, and then 3, and then 4. If I have session replication, how can I do that? Well, I can show it to you right now. This is this code snippet. I will do it like that, so perhaps there is a chance you can see it on the screen. And you can customize actually any Tomcat instance or Jetty instance through this Tomcat Servlet Web Server Factory with Spring Boot. This class is the Web Server Factory Customizer. And basically, it returns you the factory. And here I get a handle on the factory. I can add context customizer. And what I'm just doing is I'm creating a Hazelcast session manager. Very important. By default, this is true because in general, you want sticky session here. In order to have the demo, I force the fact that every time I go to a different node, which is not a good idea in production. In production, I should have sticky session. So here, I want to make sure that every time it's synchronized. In general, if you have sticky session, the synchronization strategy is much more lightweight. Here, I will be having performance issue, but again, it's a demo. So don't do that in production and implement sticky sessions. So create the manager, set the Hazelcast instance name that I want, and I set the manager to the context, and it's done. That's the only thing I need to do. So I have a Docker Compose. I will start the Docker Compose stuff. I will show it. I will show you the file just meanwhile. Docker Compose up. Ports, I must stop this, of course, otherwise it won't work. Yeah, much better. So here I have this Docker Compose file, and this Docker Compose file is composed of the load balancer, which is a HR proxy, and 2 nodes that have this application deployed with the session handler stuff. And the HR proxy is configured to have a round robin. And every time go to first node 1, then node 2. Node 1, node 2, node 1, node 2. So let's try it to check if it works. So here, first request, count 1, everything is good, so far so good. And now if I refresh, it redirects me to the second node, and if session replication works, I should have 2. Yes, I have 2, and then I have 3, and then I have 4. So the session has been replicated. Every time it's replicated, every time I do a change on the session, then the other node gets the replicated data. And now I can work in my usual way. So this is the end. So takeaways for this talk. Please remember that scalability and performance are not the same. You want a microservice architecture to scale, but as soon as you've got it, you will actually downgrade your performance a lot. So you need additional hardware to scale that. You need to scale a lot. If you want to improve performance in that case, then caching will help, but remember that the trade-off is stale data. And in the end, of course, AMDG can help you in on several layers, so that it has access, HTTP calls, and session replication. So I hope you like this talk. Be sure to read my blog. I publish weekly blog posts on Sunday evenings. You can follow me on Twitter. If you're interested about Hazelcasts and want to go a bit deeper, then you can check the documentation. And if you want to do this demo at home, then there is this GitHub repository, and I hope you can check it out and understand perhaps in a more deep way, because I have to be a bit fast. So perhaps now there are some questions. So I have a question for Hamed, and Hamed asks, so how do we handle refreshing the cache from HTTP calls? Well, that's a good question. The question is, and that's a per context answer, is it depends. Now imagine pricing. What you would do is you will always try to get the latest price. And if you run into timeout issue because the service is down, then you would take the data from the cache. And this is a circuit breaker pattern. So in that case, the cache is not used until it breaks. And when it breaks, you've got the latest data. And then meanwhile, you will try to close the circuit breaker again, try to tentatively do some HTTP calls. If it still is down, then you can still keep the data. If it's up again, then you can read the data. The quotes that I wrote from here, your question basically boils down to this stuff. Like, cache invalidation is hard. Yeah, it's very hard because if there is no hard and fast rule, basically it depends on your context. So if it's pricing, for example, then you would probably do a circuit breaker stuff and not use a cache until it breaks. In different cases, you would say, oh, I have a TTL because I don't know how, I know how long I should keep the data in the cache. I have another talk that shows you how to keep your cache evergreen, meaning that your cache is always in sync with the database. So there are a lot of contexts, and this is a very good question, but it's very general. So you need to think about your own context and apply the answer there. Other questions? No other questions? Well, it's time, so it's great. Thank you a lot for your attention, and have a good conference day. Sonra görüşürüz. Bye bye.